back with another one, folks. As we proceed to give you what you need, I'm here with another project breakdown in Python. And this one is exploring my local network using Python. So yeah, I'm going to explore my own home local Wi-Fi network using Python, and in the process show you how to do the same thing. It's kind of a cool time where because of local Wi-Fi networks, the savvy user has the capability to kind of flex their networking and programming and security skills on their own local network, kind of seeing what's going on, looking at different computers and devices and seeing what kind of information can be gathered. I think that's a cool thing about how we live technology-wise nowadays, because I remember days when it wasn't like that, where you couldn't easily create your own local area network at home, but now it's kind of here by default because of how we all use technology. So it's really cool. How I'm going to start this sucker is I'm going to gather information about my sub network using Windows command prompt commands. And so I'm really going to find out what are all the possible IP addresses available on my network. And I'm going to use that information to basically go through all the IP addresses to find devices that are active or that are likely active. I'm going to find devices that are likely active by doing what's called pinging hosts, where I'm going to go through every IP address on the local network, and I'm going to make a connection request called a ping, which is really a basic network connectivity test that says, are you up? And then they respond by saying yes. Not all computers that are active, or not all devices that are active, will respond to pings, but ones that don't, there's other ways to find out if they're active, but I'm going pretty basic here, so I'm just gonna deal with the devices that respond to ping requests. And the ones that respond, I'm gonna dig deeper. I'm going to then get information about the ones that are active that I see responding on the network. For each host that does respond, I'm going to scan their TCP ports. TCP stands for Transmission Control Protocol, and a TCP port it's like an advertisement of a service on a device. It's like saying, this service is active, come connect here and check it out. It's really, it's a way that you can gather information by certain TCP ports on certain devices are open if a device is of a certain type. For instance, Windows PCs or laptops will have certain ports open many times. An Apple Mac will have certain other ports open. A Linux computer will have certain ports open. An iPhone, an iPad, you can kind of get a signature of what kind of device something is by its open ports. The next piece, and really the last piece of information I'm going to gather on each of these devices is going to be, I'm going to get reverse DNS resolution on them to get their host name. The host name is like a computer, or really it is. It's a computer name on a network, like Dean's PC or Mike's iPhone. You probably set these names up in your phone settings. Well, these names get advertised on a local area network. So I'm going to do a thing called reverse DNS resolution, so I can get all of the device names on the network. So that'll give me more information about the devices. If I get a computer name like Dean's iPhone, a good bet that that's an actual iPhone. I can take that information along with the open ports on the system to really sort of ascertain that it's probably a phone or it's probably a PC. So it's another piece of information that I can use to gain more info on a device. Once I got all the pieces of information that I'm going to examine the results, kind of give you some findings. What can we understand about the devices given the information that I gathered? And I'll let you know, and I'll sum it up, and then we'll be on our way. We will part as friends, my friend. And that is it. There's your explanation of the exploration. Yes, hey now. I'm going to now begin the process of going about scanning my network to find available computers to get information on, because the idea of this whole thing is to scour my network to see what is out there and what kind of devices are out there using Python. But we are also going to use the command prompt, the terminal, to kind of fill in some gaps, because you don't want to just reinvent the wheel. You want to use some tools that are already available to you. So we're going to use Python and the terminal to begin things, to really begin the search, the exploration of the network. You have to know the scope of the network. Really, on a local area network these days, you're going to be dealing with contacting via IP addresses, and you got to start by knowing what the available IP addresses are on your network. So a simple utility to help determine what the scope of your IP addressing scheme on the network is ipconfig in Windows, depending on how you pronounce it. But no matter how you pronounce it, it is spelled the same way. At your command prompt, you're going to enter that. Then, depending on how many network interfaces you have on your system, you're going to get some stuff. And see, with me, I have 3 entries. Really, only one of these is valid. It says wireless LAN adapter. So I'm on a desktop with a USB Wi-Fi adapter, and so that is my main network interface. And so I've got IP version 6 addresses, and I have no idea why I have all these. Maybe I'm being hacked or whatnot, but typically I've seen like one IP version 6 address and then one IP version 4, which is kind of the normal one, and then the other stuff. But ipconfig gives you your current IP address, gives you the subnet mask and the default gateway by default. And this is useful for simply knowing your own IP address. And the useful bit of information that we're going to use for this little project here is the subnet mask. The subnet mask really tells you how many available or what's the possible scope of IP addresses on your network. The subnet mask really tells that. And a subnet mask like this, where you have 255.255.255.0, this is telling me that there are 254 available IP addresses on this network. And it's because the first 3 octets, which are what these are called, are taken up by the network, meaning the first 3 numbers are going to be the same for all the IP addresses on my network. They're all going to be the same. So the only variable part of the IP address on my network is going to be the last number after the last dot, which here on my system is 231. Because the first 3 octets are taken up by the network address and they're all going to be the same, only the last number will be variable and will be available for devices on my network. And in IP addressing, computers or devices can only be assigned 1 through 254. The 0 and the 255, those are reserved for other purposes. 255 is the broadcast address, and 0 is it was reserved for the network, I believe. So really, I guess long story short, the available IP addresses for this network are going to be this 192.168.1.1 through 254. So all the IP addresses on my network are going to fall in between the 1 and the 254 inclusive. I know that the computer that I'm on is 231, and I also know, just through experience, that my Wi-Fi router is going to be 1. A lot of you, that's going to be the case as well. Your wireless router is going to be assigned the .1 by default. And so in this project, now that I've found out this information, in this project, I'm going to do a scan basically on my network from .1 to .254 to find other available computers and devices and just see what the hell's out there. The wild, wild west, even though I kind of got a good idea because I live in the house, so I know, who's got what and what's on and whatnot. But, finding it programmatically is kind of cool. So we're going to start that idea in the next section. But this is how we found out what's available. Now we're going to scan and see what is actually active on the network. Now that we know our IP addressing scheme, we can determine what hosts, what devices are active on the network. Let's check it out. So we're now going to determine what computers are going to be responsible in the network, so then we can find information about these computers once we know that they're there. Basically, trying to find out what computers exist and on the network. And a common utility to test connectivity on a network between your computer and another computer is a utility called ping. It is available in all modern operating systems, and it's a simple connectivity test. It's just like kind of reaching out and tapping the computer on the shoulder, sort of, and saying, "Are you there?" Or a drunk text at 3 a.m. saying, "You up?" It's kind of what it is. It's the computer equivalent of "Are you up?" Are you up? You want to hang out? Blah blah blah. And computers have the right of refusal. They don't have to respond if they're available. Like computers that are more, security conscious, they don't want their kind of presence being known. They can disable the replying to a ping. I'm not going to worry about in this scenario. I'm not going to try to find hidden computers out there. I'm only going to deal with the ones that respond to the ping. So, we're just going to keep it simple here. But as I said, ping is available on all operating systems. And I'm just going to show you a couple of quick runs on Windows to show you just what it looks like if you've never seen it before. Here I am at the Windows command prompt, which is the Windows version of the terminal. Back in the day, this was the really only way to interface with computers. You didn't have the mouse and the cool graphics and such to point and click and all that. You had to type and press keys and read, and that's your only interaction with the computer. So here's how you use ping. I'm going to ping the IP address of my known Wi-Fi router. Most people's Wi-Fi routers on their networks, it is going to be 192.168.1.1. It's kind of the classic internal IP addressing scheme and the classic network address for your Wi-Fi router. Anyway, I ping it, and by default, the ping sends out four requests, and if it gets 4 back, then things are all good. If it gets maybe 2 out of 4 back, maybe there's some connectivity problems on the network, some issues. But I got all 4 back, 4 replies, and it's all good. And you see you have the time here, the time that it took to reply back. This is more useful if you're dealing with pinging computers out on the internet. Locally, it's not going to be usually more than a millisecond. That's how ping looks from within the Windows command line interface. I'm going to show you a ping just out to the internet, because I commonly use ping just to test simple connectivity out to the internet. Things are bogged down, I'm having issues, just want to see, can I get out to the internet? Of course, you can open up a browser, hop to your favorite website, but this is a little more direct in that this is just a very simple connectivity test, taking out the issues with browser and possible DNS resolution anyway. But of course, this is using DNS resolution, but we'll put that to bed. Gonna ping Google, and you see I get replies, and I get the IP version 6 address. That's just a later version of the IP protocol. It's basically saying, it's a different version, different address, but I'm getting my replies back. Notice the milliseconds is way more than on the local network, because I'm going out to the internet and coming back. So of course there's time taken up in that process. You get your ping statistics down here to tell you like min, max, and average. We're not even going to deal with all that. I'm going to use ping from within Python via an add-on module. And when I use ping from within Python, it's going to be very simple, very kind of bare bones. I'm not getting all these stats. I'm just going to do a simple connectivity. Like, I'm going to send one request and get one back. If it comes back, the system is up on the network. If I don't get anything, that system doesn't exist for that IP address. Very simple. Not going to do all this. There's just no need of it. No need of it, damn it. I'm going to use a Python module called ping3. And found this out a little while ago. It's been good for my purposes. There are a few Python ping modules out there, but this one does what I needed to do, so I used it. And if you want to install it on your own, it is a simple pip install ping3. You want to learn how to use pip? You don't really need to. You just simply do this at your terminal. But if you want to find out more, there's AI and info out there on the internet, right? This ain't the forum. So I'm going to use ping3, and I'm going to show you some simple tests with ping3, just to kind of get you acclimated to how it works, how to use it here. I got a little simple thing here where I'm using 2 forms of ping3, 2 different functions. And you see it with the import statement at the top. I'm importing a couple of functions from ping3. Importing ping and importing verbose ping. I'm trying them both out here just to show you what you get. And I'm going to end up using in my code, I'm just going to use ping. I'm not going to use a verbose ping because I just want a very bare bones simple connectivity test. But with verbose ping, you just get a little bit more information, and you can do more customizations. Like there's more options, I believe. I haven't looked into the documentation very much, but from what I've seen, that's what I know. The regular ping, it is going to simply give you the number of milliseconds that it took for the reply to come back. That's it. It's and if the host is not up or not responding, you're either going to get a false or you're going to get a none as the return. Verbose is going to give you more. And Let's see what both of these give you, because I'm calling one on one host, and then I'm calling the other on really the same host. Verbose ping is going to print something out. Regular ping doesn't print anything out. It instead returns something, either a float, a boolean, or none. Let us run ping test. Now we get down here, the first line of output is going to be the output of the verbose ping. The verbose ping is just, it's showing me the word ping, the device IP address, and the number of milliseconds it took. The second line is regular ping, and it simply gives me the number of milliseconds. And that's really all I need. I just want, did this connect or did it reply, and maybe how long it took for a slight bit of amount of more information. I just need either the time or it didn't reply at all. So I'm gonna use this one in my code. Of course, feel free to experiment with verbose ping to your heart's content. Now I'm going to show you what I did to gather more info on my network with this code right here. On line 1, I'm importing the ping function from ping 3. I'm not using verbose ping. And let me set the stage here before I get into this line by line. The stage here is that I'm going to ping every available IP address on my network. In the previous section, I found out that the available addresses on this subnet are .1 to .254. So I'm going to really loop through all those addresses, and for each one I'm going to run ping against that address for .1, .2, .3, all the way up to .254 to find how many systems on my network will reply to the ping. And as we begin here with the begin string, the string is going to be the network prefix of all the IP addresses that I request pings from. So this is a network address. Determine that the first 3 octets are for the network. So all of the IP addresses on my network are going to have this prefix. It's probably the same on your network because this IP addressing scheme is extremely common for home networks. I start I at 1 because I is going to be the network portion of the address, and it's going to start at 1, meaning the first IP address that I request is going to be 192.168.1.1. Ping report. I am going to list all of the computers, all the systems that respond to my ping. I'm going to put them all into a string, and I'm going to write that string to a file to save a report so that I can look at this text file basically and see which systems responded. I begin my while loop while I is less than 255. So it's going to loop from 1 to 254 using this condition. I set up the string for my current remote computer that I'm going to request. So it's going to be the network address plus the host address, which is I converted to a string. So this builds the IP address. It'll be stored in host. And then line 10, response. Here I am going to run the ping function. And the ping function, its output is going to go into a response. Line 11, if response, this is simply saying if response is true. If response is true, it's going to be a float which will be the number of milliseconds. If response is false, it's going to be either a Boolean false, or it's going to be the value none. Both of those really mean false in conditional cases. So I am not going to handle them, because that means either the computer didn't respond or it just doesn't exist on the network. I only want to deal with ones that reply. So I'm handling if response. So if response, should have gotten rid of that comment there, earlier code. But if it responds, I'm going to get the response time in milliseconds, and I'm going to get the IP address. And I'm going to add that to my string that I'm using for the report. After that, I'm going to put a dashed line, because I'm going to use a line to separate each system that responds for easier reading of the text file. Then on line 15, I am going to increment I, because next IP address. And then down here, line 17 and 18, I create the text file that I'm going to write to, and then I write to that text file. Simple as that, folks. And after this is done, I'm going to have a text file with the computers, with the devices that responded. Now, I'm not going to run it right now. I'm going to simply show you the output of the code, because it takes a little bit of time to run, and you don't have the time to wait, right? Neither do I. So I'm going to show it to you right here. The cake comes out of the oven. These are the systems that responded. And this is my wireless router. This is the system that I'm talking to you from right now. So in between those, I've got a few other systems to check out. And I'm going to check out all of them really here pretty soon. So next I'm gonna basically port scan all of these devices to find out a little more about them, and maybe I can determine what kind of devices each of these is. But whatever I do find, you'll see it in the next section. But that is it for now. And with that, I bid you adieu and see you in the next section. To recap the last module, what I did was to probe, to scan the network to see which devices responded to my pings. So yeah, I think you remember, you probably just watched it, went through the network to see who responded. So now we've got a list of computers that responded to the pings. Now it's time to dig a little deeper to see what TCP ports are available or open on each of these devices. And TCP stands for Transmission Control Protocol, and finding these open ports really will tell you what services a device is offering on the network, or well, yeah, basically that. And what it's going to tell you, in addition to what it's advertising basically, which is kind of what a TCP port being open is, it gives you a clue as to what kind of system, what kind of device this is. Certain kinds of operating systems, certain kinds of devices are going to have certain TCP ports open. Like Windows is going to have certain ports open. An Android device perhaps, or a Roku device, which is got a lot of those on my network, and Mac OS, Linux. These are going to be serving up different ports, and this is all a part of the information gathering process. So you find out more about systems by doing TCP port scans, and really this entire process is about it's just very basic information gathering. These are some of the preliminary steps a a security enthusiast or so-called hacker may do on a network to get a lay of the land. Basically, they're going to do it in a more advanced way than you're seeing in these videos, but they're going to hop on a network, see who's available, maybe through pings, maybe through something a little more technically savvy, and then they're probably going to scan the devices they find active. Doing TCP port scans will be one of the things, but they'll probably do other things. Probably got other things in their toolbox, but the whole idea of this project is to kind of give you a very kind of general early look at how to do this kind of stuff in Python. It can be kind of something that kind of sparks the fire for you to investigate further on some of this stuff. And now that we set the stage, let's get into this mother and start where we are. Start at the beginning. So a list like this in a text file would be the result of the code from the last module. Scan the entire network, all the IP addresses, and whoever pings back, I put it in a text file. Now, I've done these scans bunches of times during the life of this project, and as you might guess, I'm going to get a different amount of computers responding back each time because devices may be off the network, they may be turned off, things like that. So, long story short, the number of devices I get are going to be inconsistent, but and you may see that in some of these, but just understand that is the case because these scans are not all happening in real time. You're going to see some old ones, some newer ones, blah, blah, blah. So it's going to be a different number. Anyway, we start with a list of hosts that responded. And now I'm going to take this list and plug it into this new code because in this module, to get down to brass tacks, what I'm going to do is for each active device on the network, I'm going to do a full a scan of all the TCP ports. Now, there's a lot of TCP ports available on a system. There are 65,535 ports possible open on a device. That exist. They're not all going to be open, of course. I don't know why I said it like that. But to see which ones are open, doing your due diligence is to scan all 65,000 plus. And that's what I'm going to do, just because I got a computer and, you can automate things with code. So why the hell not? Why cut it off at 1,000 or 2,000? No, let's just go the full 9 or the full 65,000. So that's what I'm going to do here. And so now it's time to show you this code. Without further ado, in a little preview here, if you look at line 36, I put all these hosts in a list. And again, you're going to see a different amount of computers than you saw in the text file, because maybe this was a time when I got more computers in my scan, but I just manually put them in this list because I'm doing enough automation, blah, blah, blah. And it's only 10, 12 of them. So easy enough to copy and paste them into this list. But what I'm going to do is I'm going to loop through this list. And for each one of these, I'm going to scan all their TCP ports to see what's going on with each of them. Like I tend to do, I'm going to start the code at the top or start explaining it at the top, which is kind of what you should do usually. So I start with what I'm importing, like what libraries, what modules am I including here. So focus on these three at the top, because these kind of, when you read the modules that are imported, it kind of sets the stage for outside stuff that I'm going to use in the code. So the first one, socket. Sockets. This is a library that's going to allow for the network communication, basically. When you, if you don't know about sockets are really generally a library to craft network packets in a given programming language. And most modern programming languages have a sockets library or module in their stuff, basically, to allow you to communicate over networks by crafting network packets. Obviously, Python has one, Java, C, C++, these all have socket libraries, and they're all called sockets. And it is for crafting network packets. I'm going to be using this to actually do my attempts at connecting via TCP to the devices on the network. Next, I got the threading module. Threading is for multi-threading. The way I'm going to use it is, I told you I'm going to be scanning 65,000 ports. If you do that sequentially one after another, it's going to take a hell of a long time. I'm going to use multi-threading so that I can run port scans concurrently, meaning at the same time. So instead of running one, having it complete, then another, having it complete, I'm going to run several at the same time using threading. Threading is kind of a cool concept. I don't use it very much, but the idea is run processes at the same time. That's what threading does. And in operating systems are multi-threaded in that you got a hell of a lot of programs running at the same time. Think how useless your computer would be if you could only run one program at a time. Like, that would be insane. That's back in the day kind of stuff. But threading allows you to do the same thing in your code, run multiple basically streams of execution at the same time. Then we'll look at the DNS resolver. This is going to be used because I'm going to take my IP addresses of the devices and resolve them to their computer names, like the device names, like human readable names. And I'm doing that because I want to basically get the computer name to find out more info about the device. Because like I said before, if I have a device that is, Dean's iMac, I kind of have a good idea of what kind of computer that is just right off the bat. And this is all about gathering information about the devices on the network. So that's why I'm doing that. Getting into the code, looking at line 5, I'm creating an empty string called pscanlog. This is going to be my logging string. Just like the code in the last module, everything that I do in this code, I'm going to write it to a string, and that string is going to be written to a text file so that the results of all my network or all my port scanning are going to be in this text file. So for basically storage, like if I run this and I see the display and I see what ports are open, blah, 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 what if I want to save it? Well, it's going to save automatically. So I'm going to have a display where I can read it on the terminal, and I'm going to have it in a text file. So for more permanent storage. So that's what pscanlog is for. Now a sort of function on line 7 called reverse DNS. This function is going to do like it says. It's going to do a reverse DNS query. Given the IP address of a device, it's going to use DNS to get the computer name called the host name of the device so that I can record that as well so that I can get more information about the system. And it uses a try and accept block where it attempts to do the resolution from IP address to host name, and if it doesn't work, I have it simply returning the IP address. So it's like no harm, no foul if it doesn't work. you just keep the IP address, blah, blah, blah. We will continue. I've been saying blah, blah, blah a little bit too much these days. Yada, yada, yada. The next function is really the meat and taters of the thing, however you say that. The scan port function. This is going to attempt to connect to a single TCP port on a device. One port. That's it. How I'm going to use this function is I'm going to loop through all the ports on a device, and for each port I'm going to run this. So I'm going to run this scan port 65,000 plus times per system that I go and look at. And how it's going to work is that I'm going to run each function call in its own thread so that many of them will happen at the same time, thus speeding up the process. Or I'm not going to wait for one connection to happen, then another one. Depending on how the code runs, I may do 50 at the same time. But this function is going to do one port, but I'm going to be running this a bunch of times. So line 22, I do global pscan log. This is saying that I'm going to use a variable called pscan log that is defined globally outside of this function. It's really to let the code know that I'm going to use a pscan log variable that's defined earlier, not creating another one locally in the scope. So I know people have things to say about global variables. Shut up. This is just a demo type of deal. This is not production code, so it's fine. Get over yourself. So my message to those opinionated programmers out there. I know there's a hell of a lot of them. But yeah, I'm going to use that same string in here to write to the log file. And I'm just saying that variable is the same one that's defined earlier, not one that's being defined in here. All right, line 22, enough said about that. Line 22, I create my socket. And this is creating the TCP packet, basically, that I'm going to send out to the remote device. And these arguments specified as TCP. AFINET for like I think generally a TCP IP packet is going to be use this option, and then sock stream actually specifies it as TCP. If you want to do UDP, which is another protocol, you would do sock dgram, stand for datagram, but sock stream is for TCP, and that's across any socket library. Line 23, I set the timeout so that it's not going to hang. It's either 1 second or 1 millisecond. I don't remember. I know somebody out there knows. Obviously, because somebody created it. Line 26, actually line 24, I do a try and accept, where I'm going to attempt to connect to that port. And if it fails, you get the exception, I think. Yeah. So, actually, well, I don't think you get an exception if you don't connect. But anyway, I'm going to attempt the connection, and if it connects, I'm going to print that it connected, and I'm going to write to the log. So every time I connect to a port, I'm going to display it and I'm going to log it to indicate success. Like, I connected to port 80 on this host, blah, blah, blah. There's a blah, blah, blah again. Got to stop that. Exception, or accept exception. If there's a problem, I'm just going to silently continue. Like, just go forward. Finally, I'm going to close. So no matter what happens, the socket's going to get closed. The network connection is going to get closed after the attempt. Now I'm going to head down to the main section of the code. As specified by that beautiful comment on line 34, this is the main part of the code, and line 36. This is my list of computers that I'm going to scan, or list of devices. I keep correcting myself, devices that I'm going to scan. Line 38 kind of begins the scan, or the loop where it's for host and host. Hosts is the list. This is a for each loop. So it's going to be, one per iteration. Line 40. I get the reverse DNS and put it into host name. This is going to be the computer name. So I'm getting that computer name for information, of course, like I said. And then lines 41 and 42 are really headings, where in the text file or on the display, it's going to say, these are the open ports on 192.168, whatever, as a heading. And then after that heading, I'm going to show the open ports via that scan port function. And that scan port function is going to run in this for loop. So in the for loop, I'm going 1 to 65, whatever. I'm scanning all the ports. This is scanning the ports on the device. Lines 45 and 46, I create a thread for each port, and the argument to thread is going to be the scan port function, which is the function I'm going to run for this thread, and the arguments for that function. So I'm going to call scan port with the argument of the IP address and the port. I is going to be the port, because I is going to contain either a number between 1 and 65, 535. Start that thread, go to the next one. So using this loop, it's going to, for each iteration, it's going to start a thread, and each thread is going to contain an instance of that function call. And each of those threads is going to return something, going to print something out perhaps. Once the loop is over, I print a dashed line, or I write it to the log, or actually both. This is going to go underneath to separate one computer section from another one. It's like, these are the open ports, and then there's a dashed line, and then it's going to go on to the next computer and the next one. Yeah. Also notice I have a nested loop here. So like for each host, scan the ports, and then next host, scan the ports. Keep going like that. That's the flow. Once that nested loop is over, I am going to write to my log file. I'm going to call it network scan log.txt, and then call write, and I'm going to write that string pscan log to that file. There's the code, folks. And let's look at the output. I'm not going to run it now because it takes a decent amount of time. I don't want to take up 5 minutes of a video twiddling my thumbs. So of course I can just show you what the output looks like. Here's the output in the console, or the terminal, whatever you call it on this thing. See, here's the heading, open ports on the device. And you see for some of these you'll see a host name. Some of them you won't. It's because if it can't resolve the host name, it's just going to give you the IP. And if you rewind, you'll see that in the code, or you can just look at the code in the folders. Yeah, one of those two. So it shows the open ports. So for this first one, you see 5380.443. 53 is DNS. 80 is HTTP, which is like a web server, and 43 is HTTPS, which is a web server with SSL, secure web, as they say. Notice the S for secure. This is my Wi-Fi router, and if you think about a Wi-Fi router, you might be, understand that these are the ports that would be open on a Wi-Fi router. The two web interfaces are going to be for the web interface to configure the Wi-Fi router. Typically, that's how you're going to connect to it to change stuff and mess with things on the router. Wi-Fi routers are also usually DNS servers on a network. Yeah, also DHCP servers, but some of y'all probably know that. So looking at these other ones, like you see it resolves the host name, where you can kind of tell this is probably a phone. This might be a phone. This is going to be a Roku device. And you see the weird ports that are open on the Roku. You could use, AI or Google to investigate these ports and find out if you can kind of dig further and monkey around with them. Like if there's some kind of service you can try if you connect, via something to these ports. I have no idea. Never really investigated, Roku security probing, but really looking at these, you got a clearer picture of my network where I can see some devices, and I got a lot that didn't resolve, but you can see port numbers. And if you look up these TCP ports, you can find out what services are generally offered there, and really you can query various things on the web to say, if I've got a device that has these ports open, what device might it be? And then it'll tell you. So, information. Clearly that's an Amazon device. Yeah, no shit, right? And this is a Roku, and this last one is my own. I have no idea why all these ports are open. This actually may be other devices, because this is a multi-threaded thing. Like some of the scans may have returned down here instead of up there, so things may be out of sequence. But a lot of times when you're scanning yourself, you may see more open ports. But I'm on a Windows device where the firewall is down. It's disabled, so you're going to see more open ports. And I was saying that you can identify a device by the open ports, like what kind of device is it. These ports that are open are synonymous with Windows. 135, 139, 445, 3389 is a remote desktop, so it is a Windows system. Yeah. So those are examples of info you can derive from looking at a TCP port scan. Now you've seen the code and you've seen the outcome, and that is it for this section.